Okay, kids, this is the going over the review, the multiple choice review for the final. Number one, it says solve for x. It's x squared minus x minus 12. First step there is you need to factor. I need two numbers that multiply to a negative 12, add to a negative 1. I can do that because the coefficient is 1 there. Those numbers are negative 4 and 3. When in doubt, you FOIL it out. So, since it would FOIL out to be correct there, now am I done? No, it said solve for x. So what I have to do is set each of these binomials equal to 0, like this. And then you should be able to solve that. 4 and negative 3. You can put that into the function, substitute it, and solve, and see that it works, which it does. Number 2, solve for x. 3x squared plus x minus 2 equals 0. I can't do the trick I did last time because of this coefficient of 3. I must use the rubber band method. So I multiply that 3 times that negative 2 and get negative 6. So I find two numbers that multiply to negative 6, but add to that middle number of 1 there. That would be 3x and negative 2x. Negative 2 times 3 is negative 6. 3x minus 2x is a positive x. Then I group the first two and last two terms together, pull out a GCF. It's 3x for this first one. It's a negative 2 for the second one. And lo and behold, now I have x plus 1s. I can yank those out, and I'm left with a 3x minus 2. Not quite done yet. Set each of those factors equal to 0 and solve. And then you can substitute the answers back into the problem to check. All right, number 3, again, it's a 4-term polynomial. If you're on your factoring sheet, 4-term polynomials, scream factoring by grouping. I group the first two things and last two things together. First two things of a GCF of 2x. Last two things of a GCF of negative 3. Now look, there's an x plus 2 left. Pull that out, and I'm left with 2x squared minus 3, setting each of those equal to 0. When you solve this, you add 3 and divide by 2, and then square root. Now notice I had root 3 over root 2, because when you square root there, you'd get 3 halves. Square root of that, you get root 3 over root 2. Can't have that, need to rationalize. So multiply top and bottom by root 2. Why is it plus or minus? Because I took a square root. All right, graph the parabola. That's a good old-fashioned t-chart. If you wanted, you can find the vertex, which is negative b over 2a. That's negative 8 over 2 times 2 there. That would give you the x-coordinate. You put that x-coordinate back in to find your y-coordinate. Good old-fashioned t-chart here. Now, look at negative 2 and negative 1 when I put an x. They're way off my graph here. So I can't plot that point because that's too many tick marks for me. You could, but it's not really needed. So you create a t-chart, nice smooth curve, arrows at both ends. Once you find your vertex, it's symmetrical around that. So looking at 3 here, I got 0, which is 1 away from my vertex. So is this one, also with 0. So if I were to put, let's say, x equals 4 in, I'll get back 6. Symmetry. All right, number 5, it's a multi-step problem. Describe left and right end behavior. You look at the biggest exponent there, that's right there. X to the 4th. Put a positive number in, which is what's going on right here. Put a positive number in, a positive number to the 4th power, positive. So as you get x is going up, more positive, y's also go up. Pick a negative number to the 4th power, also is going to go up. So as you put really small values of x in, really negative values, you're still going to spit back a positive number. All right, find the possible rational zero. It's p over q, p for possible. You take all the factors of your n number, which is 6, divided by all your factors of your q, which is your queen, the one next to the most power, the biggest power, which is 1 here. All the factors of 6 are 1 and 6 and 2 and 3, plus or minus in front of all of those. Now, find all the zeros. So here's what you do. Use some of those p over q lists using synthetic division. And my coefficients come from this right here. 1, 1, negative 7, negative 1, 6. Like that. I picked one of my zeros. 1. Do the synthetic division. Lo and behold, it worked. So if 1's a 0, x minus 1 is a factor. Opposite. Now, I take this list right here. I'm going to use this list, that 2, that 1, that negative 5, and that 6, as my new numbers I'm dividing into. I pick another 0 from my rational 0 list. I pick 2 this time. Lo and behold, it also worked. So if 2 is a 0, x minus 2 is a factor. Now I have this junk left, this 1, 4, 3, and 0. No remainder, which is what I want. Constant term is 3. My x coefficient's 4. And my x squared coefficient's 1, like that. I can factor that. Now, here's the complete factored form. The opposite of my factors are 0. So x minus 1's a factor. 1's a 0. X minus 2 is a factor. 2's a 0. X plus 3 is a 0. Or x plus 3 is a factor. Negative 3 is a 0. X plus 1's a factor. Negative 1's a 0. Right, the complete factorization. If you do step or part C here, finding all the zeros like I just did right here, you already have part D done for you. Find the x-intercept. X-intercept, remember, you let x be 0. When you're looking for an intercept, whatever intercept you're looking for, the other value becomes 0. Done. So you put 0 in here, all the x's get covered up. Gone, 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 gone. Oh, look, 6. Then sketch the function. That's easy enough. So you know what the x-intercept is. It was 6. Boom. Or the y-intercept, excuse me. Y-intercept 6. Done. Right there. Yeah, there we go. Then you know zeros. Negative 1, 2, negative 3, and 4. Negative 2, negative 1. Do like that. And then you just graph. All right. Complete factorization of this for number 6. Well, first thing you do in factoring is GCF if you have it. We do have one here. 4. Then you can just factor that. Two numbers that multiply to negative 6, add to a 1, positive 3, and negative 2. You could also factor it using the Rand method. You will get to the same answer eventually, but it will take you much, much longer, and you have more of a chance of making a mistake. Find the remainder of the function when divided by the expression x minus 3. Okay, here's the issue I have. Find the remainder, x minus 3. If I divide by x minus 3, remember, the plus 3 goes in my box there for synthetic division, opposite of whatever that is. Just like we did when we were factoring out my binomials. Now, why do I have a plus 0x squared? Because I go x to the 4th, x squared, x, and then my constant. I need a placeholder in synthetic division for my x to the 3rd term. So I go 0 for that, a 1 for my coefficient of x to the 4th, an 8 is my coefficient of x squared, a 4 is my coefficient of x, and negative 10 is my constant term. You drag down, multiply, drag up, and add. Multiply, drag up, add. Multiply, drag up, add. And your remainder is 155. Find all the real zeros there. All right, you get your P over Q list. Boom. You pick one of those P over Qs. I pick negative 1. Go through. Oh, no remainder. That works. So if negative 1 is a 0, then I can use these new items as what I have left, x squared plus x minus 6. I can factor that, and the opposite of these factors becomes zeros, like negative 3, and see that's x minus 2, positive 2 is a 0. And I already have my negative 1 being a 0 because that's the number I found out that worked in my box. Write a polynomial function that has the given zeros and a leading coefficient of 1. Well, that's pretty interesting. Remember, if they give you the zeros, the opposite become my factors. 6 is a 0, negative 6, x minus 6 is a factor. Negative 2 is 0, x plus 2 is a factor. 1, x minus 1. Negative 1, x plus 1. And it's some good old-fashioned FOIL action, folks. FOIL these two, you get x squared minus 1. FOIL these two together, x squared minus 4x minus 12. We've done these before. Multiply everything by x squared, everything by negative 1, and combine your like terms. Okay. Dividing by something. Instead of dividing by something, I multiply by its reciprocal. And then I go ahead and factor every part of every fraction. 5x doesn't change. I can pull a 3 out of this 3x minus 12. This factors into x minus 2, x minus 4. This just has an x. Now you cancel out like terms because everything is linked with multiplication. X's go away. X minus 2's go away. X minus 4's go away. After all the carnage, you're left with 5 over 3. Solve. Okay, what I do here is I find what my LCD is. It's x minus 1, x plus 1. And then I multiply every single item by my LCD on the numerator. Why do I do that? When I do that, it kills off every fraction. So here the x plus 1s kill off. I'm left with the x minus 1 up top and the 2. Here the x minus 1s die off. I'm left with the x and the x plus 1. Here everything died off because that is my LCD. I'm left with 2. Then you set it equal to 0 and factor it. Now, I got two answers here, -4 and 1. Why doesn't 1 work? That's the question I have. Why did I cross out 1 here? Remember, put 1 into all my denominators. 1 plus 1 is 2. Good. 1 minus 1 right there. Yee. Yee. Yeah, about that. That's dividing by 0. No dice. If I put -4 in here, that would give me -3, -5, and a 15. Not 0. So x minus 4 is good to roll. All right, this one, pretty straightforward. I'm going to add across the top, getting a common denominator here. So I need that to be -10/2. Cut across the top. Here I get a common denominator. Add those up. Instead of dividing by something, folks, I multiply by its reciprocal. Done deal. All right. These you just cancel out like terms. They're all linked with multiplication, so the x kills off with that x to the 5th, leaving x to the 4th. 7/21, 1/3. Then, oh, look. How'd I get y to the 10th here? Well, I had y9 and y. It's y to the 10th. Y to the 10th over this. Y to the -2. Remember our quotient property from chapters 6 and 7. Do 10 minus a -2 becomes +2. That's y to the 12th. And then a 3 times a 3 makes a 9. All right, here. Anything to the 0 power. 1. X to the 4th. When the exponent is negative, you throw it in the basement and make it positive. Done deal. Here. Quotient property again. You have x to the 3rd and x squared on bottom. 3 minus 2. That means there's 1x up top. Y to the 9 minus a -2. Numerator minus denominator becomes a plus 11 up top. 5/20 becomes just 1/4. And simplifies down to that right there. Power to a power you multiply. So I take everything to the -2nd power. I don't multiply 4 times -2. I take 4 to the -2 power. All these exponents are now negative, so they all flip to the bottom of the fraction and become positive. X to the 4th is okay. Y to the 10th is okay. 4 squared is 16. Done deal. All right, here. This is tricky. I only flip the second one. It's dividing by that term, so I only flip that one. This other one's multiplication, that stays. So instead of 1/x minus 6, I get x minus 6/1. Then I go ahead and factor every part of every denominator and numerator. So I factor that x squared minus 9 into x minus 9, x plus 9. The x is the only thing that cancel here. That's it. Everything else stays. So I'm left with a 5, x minus 6, x minus 3, x plus 3. Kind of gross, but it works. Okay, here. I am dividing by this, so I'm going to multiply by its reciprocal, and then I'm subtracting 1. All right, well, I factor everything. X squared plus x minus 12 factors to that. X squared minus 2x plus 3 factors to that. I then cancel everything relevant here. X minus 3's cancel. X plus 1's cancel. I'm left with x squared over x plus 1 minus 4. Now, there what I end up doing is I'm subtracting 1. Need a common denominator. That would be an x plus 4. Give it to the bottom. Give it to the top. So I have x squared minus x minus 4 over x plus 4. That does not simplify. You are done. Okay, this. I'm taking the cube root of 48. That's a 3 there. That means I need to break 48 into something times something. And one of those somethings, one of those terms, needs to be an item to the 3rd power. Well, 48 breaks down into 8 and 6. Why did I break 8 down? Because 8 is really 2 to the 3rd power, which, remember, pays the evil troll toll, and the 2 walks out. And the cube root of 6 just stays. So this is 1 to 19. And we are going to get to 20 on the next review. So that was 1 to 19. Take a break, get a sandwich, and come back and keep reviewing later. Whoop, whoop.